Our song today is Sister Christian, and our topic is linear inequalities. Excuse me. So we're going to be able to graph them on a coordinate plane as well as write the inequality from a graph and use them to solve problems. No vocab today. We're going to graph our inequality, and what I notice is that the form that this inequality is in leads me to think that the intercepts is the easiest way to graph it. So remember, solving for the x-intercept, I'm going to substitute 0 for y, which cancels that term. I'm going to set it equal to 12 because this will be what my x-intercept is equal to. So of course I get an x-intercept of 4. And I'm sure most of you guys can do this in your head, which is great. I would expect you to. For those that want me to show my work, substituting 0 for x cancels that term. Dividing by 4, and I get my y-intercept. I'm going to graph 4, 0, and 3, 0. And before I draw the line, I'm going to ask myself, is the boundary solid or dotted? So similar to when we solved an inequality in one variable, the or equal to means that the boundary is included as part of the solution, so it would be a solid line. If it were not equal to, it would be a dotted line. The boundary would not be included. Make sure that you think about that before you start graphing. Then we need to figure out which side of the inequality to shade on. What I like to do is use a test point. 0, 0 is the easiest test point. We substitute that back into our original inequality and then ask ourselves, is it true? Well, 0 plus 0 is 0. Is 0 less than or equal to 12? Yes, which means that 0, 0 is included in the solution, so that's the side of the line that we will shade on. Our next example, we have the inequality graphed and shaded, and we need to write the inequality itself. So I'm going to go ahead and use point-slope form. Actually, I'm going to use slope-intercept form because my graph has a nice, precise y-intercept, and I can count from my slope. So my slope is negative. I notice that my line is falling, and I've got a slope of 1, 2, 3 halves, and my y-intercept is negative 8. So putting this into an inequality, remember, not an equation, and my line is dotted, so this will just be a greater than or just a less than. I'm going to figure that out in a second, so I'm going to leave a little space for my inequality symbol. And we're going to figure out how to determine if this is a greater than or a less than. Well, the point 0, 0 does not make it true, so I'm going to pick a point that does make it true, and then figure out which way the inequality needs to face. I'm going to try and use an easy point. So this one right here is negative 6, 0. So I'm going to substitute negative 6 for x and 0 for y. And I'm going to figure out which symbol will make this true, a greater than or a less than. So multiplying my negative 3 halves by negative 6, I'm going to get 9. And is 9 minus 8, or 1, greater than or less than 0? Greater than. So it will be y is less than negative 3 halves x minus 8. We only have one example left. This video might run closer to 6 minutes, but better than splitting it up into a 1-minute video for the second one. So we're going to take a look at applications of inequalities. A thrift shop has an overhead. What that means is that's what they pay every month to run their shop, $2,300. The skim boards sell for $115 and long boards sell for $685. We need to know how many sales in order to earn a profit. So I am going to, first of all, identify my variables. I'm going to say x equals skim boards and y equals long boards. So to figure out how much money they make when they sell skim boards is you would take the cost, $115, times the number of skimboards they sell plus the 685 times the number of longboards. And in order to make a profit, they have to sell more than they pay. Not more than or equal to, that still wouldn't be a profit, more than what they pay for their overhead. So I'm going to label my graph. And then I'm going to figure out how to graph this. I'm going to find my intercepts, which may not be exact values, but remember the graph is one representation, and it doesn't necessarily take into account the fact that you can't sell half a skimboard. So we're going to think about that as we're graphing. All of the integer ordered pairs would be legitimate responses. It's still easiest to represent this with a graph. So my x-intercept, or the number of skimboards they would need to sell, I'm going to divide the 2,300 by 115. So that would be 20. And the longboards would be 2,300 divided by 685, which in this case gives me, and I'm going to round to one decimal place because on a graph it doesn't make sense to keep much more than that. They'd have to sell about 3.4 longboards to earn a profit. Alright, so I'm going to get this out of the way since it's running over my graph. Hopefully you guys have that in your notes now. And to go up to 20 on the x, I think I'm going to do this by 2's. And then the longboards is 3.4, so I'm going to scale this by 1. Graph my intercepts. This will be a dotted line because our inequality was greater than 2,300, not greater than or equal to. And I am not going to sketch arrows because you can't sell a negative number of skimboards or a negative number of longboards. So in the context of our situation, this is what makes sense. And of course we said more than. If they sell 0, they're not going to make a profit, so we're going to shade this way. Alright, sorry this video went a little bit longer than I anticipated. The last page is our U-try. And if you're interested, the song is Sultans of Swing by Dire Straits.